We had to solve a new Leet code problem, that is longest continuous subarray with absolute difference less than or equal to limit. So let's understand the problem first. In this problem, we have been given an integer array and a limit. Now you have been given this problem to determine the longest subarray that can be formed such that the difference between any two integers in this array must be less than equals to this limit, that is 4. So let's understand how it is so. Let's take, if you consider this subarray that is the consisting of only 8, the difference between 8 and 8 will be 0, which is less than equals to 4, so it can be allowed. Now, if we take this subarray that is 8 and 2, the difference between 8 and 2 will be 6, that is greater than 4. So you cannot allow this to have this, because since the difference is greater than this limit, so I cannot allow this. Now, if we take this subarray, that is 2 and 4, the difference between 2 and 4 is 2, so it is under the limit. So I can consider this length, so it is 2. Now, if you take this one, take this subarray, the difference between 2, 4, 7 is 3, which is okay. But the difference between 2 and 7 is 5, which is greater than limit. So it is again becomes invalid, because we cannot have a subarray which cannot, which where the difference between any two integers is greater than limit. So so the 2 and 7 of this subarray violates the constraint. So I cannot take this. Now, in such a way, if we apply all sorts of combinations, we will know that this subarray 4 and 7, 2 and 4 will be such subarrays which satisfies our criteria. So 2 and 4, 4 and 7 is of length 2. So 2 is the correct answer. This is the this is how the problem wants me to do. So let's take in another test case. This is 10, 1, 2, 4, 7, 2, and the limit has been given 5. Now, if we take for this subarray 2, 4, 7, 2, the difference between any two integers, if you say, it is less than equals to 5. Because, yeah, so this satisfies the criteria, and the length of this subarray is 4. So, 4 is the maximum that we can get. So, this is how the problem is. Have you noticed one thing? Because we do not need to check between all the integers, just find out the minimum of all and the maximum of all. The minimum of all is 2 and the maximum of all is 7. So if you find the difference between 2 and 7, it is 5. So can I restate this problem in such a way that find the longest continuous subarray with absolute difference between the minimum and maximum of the subarray, such that the difference falls under the limit. So we don't need to check for difference for all the elements, but for the minimum and maximum elements. So can we solve this problem using what we know? Because if you understand carefully, if this problem wants me to find the subarray, right? The subarray can be of any size. So it, from the problem statement, it is evident that it needs some kind of sliding window approach. For example, if you take this subarray, let's say this one, then the minimum is 1 and the maximum is 10 and the difference is 9, which doesn't allow the condition. Now, if we eliminate this part and if we include this part, the minimum is 1 and the maximum is 4. And the difference between min and max is 3. So it satisfies the criteria. So by this way, by this sliding window technique, we can have this subarray that satisfies the criteria. So it is almost a sliding window approach. Those who have solved a lot of sliding window technique will know this gives away very sliding window vibe. So how to do this thing? Since like every sliding window, we will take a pointer left and right that will denote the boundaries of the window, and for every element that comes, we'll check the maximum and minimum element that is already present under my subarray. For example, under this subarray, the maximum was 10 and the minimum was 1. So we need to track the maximum minimum present for the subarray. Now it doesn't falls, it doesn't satisfy this criteria. So what we will do? we'll keep moving, we'll keep removing the left pointer, that is the element that is present at the front of the sliding window. So after removing, we try to include the next element, which is 4, and try to know whether the maximum and minimum difference falls under this limit. So let's solve this problem. So to do so, first of all, we need some data structures to track the maximum element and the minimum element for each and every slide, for each and every rotation. So to track those things, we need some kind of data structures, right? So what kind of data structure it can be? It can be a heap data structure. We need both max heap and min heap, because max heap will let me know the maximum element that is present at the subarray, and the min heap will let me know the minimum element that is present at the subarray. So let's do this thing. Let's take a max heap. There will be another heap called min heap, because I need both max heap and min heap to track the minimum and maximum element present, right? Let's say min heap will be normal priority queue. Generally, all priority queues are by default min heap in Java. No need to do any kind of drama, extra things. Now max heap, to get a max heap, I need to do collection dot reverse order, because it will be reverse, na? Reverse order. Yeah. Now we have a mini and max heap. Now we need two pointers, that is L and H, right? And also the length I need to know, that is nums dot length, because every time nums dot length is not a good option. So let's determine it first. Nums dot length, okay, we have L and H. Now I will try to keep moving my H, that is the right of the window, and every time we move an H, we try to push this element to both of these max heap and min heap, because the current element can be the maximum element of the subarray, and the current element may also be the minimum element of my subarray. So let's push this thing into the max heap and min heap. Now let's test the condition. If my max heap dot peak, if the difference between the maximum element and the minimum element is greater than the limit, then it means I need to pop something, right? So what to do? I will first store this thing. Now from where I will prop? I will prop from the beginning, from the front of the subarray. So it will be nums of L. So let's pop this thing. I will pop this object from the min heap. Let's not use pop, because let's use min, because it can be possible that the element that you need to pop is not in the front. So let's use key. Okay. So we pop the element from the, now you need to increase the left pointer, because I have removed the first element. So it is okay now. Now till the condition is true, that is maximum element and minimum difference is greater than a limit, I need to pop element. I need to move the left pointer of my sliding window. Now after doing everything, we'll try to know the count. Let's say this is the count. First of all, the count is 0. Now I try to know the maximum that we have experienced. Now maximum will be, so let's say my left pointer is at here and right pointer is at here. That is 1 and 3. Now in between 1 and 3, there are three elements present. So 3 minus 1 plus 1, that is 3 minus 1 plus 2 plus 1, that is 3. So it will be h minus l plus 1. This is the count that I will get. Now don't forget to increase the h, because I need to move the high pointer always, right? To, because unless I do so, or my sliding window won't slide rightward. So this is it is. Now let's return the count. My count will have the answer. I do get a wrong answer. Why it is so? Why it is so? I did something like queue, priority queue, both are priority queue, it is collection and reverse order. I offered both of them nums of H. I removed from both of them, that is nums of L. Sorry, don't do this. No, it's okay though. Sorry. Yeah. Now after doing this thing, I'm just trying to know the count, that is math.max h plus plus. It's giving me some problem. What's the problem? It is giving me output is for expected is 2. Minimum heap I'm offering, maximum heap I'm offering. Both mean heap, maximum, okay. Maximum heap, sorry, maximum is minus mean heap, sorry. Yeah, it was the problem. It was the problem. It was, yeah. Let's submit this. Because I need to know the difference between the maximum element and the minimum element. Maximum element will point the maximum element of the survey at the peak, and the mean heap will always keep the minimum element at the topmost at the frontmost element of the queue. So this should be mean heap. That was the problem. Yeah, it passed, and the time complexity for this problem will be order of n for this loop, while h less than n for this loop is n, and for every time we do offer or remove, it takes a log of n. So it will be, the time complexity will be tc of n log n. This is the time complexity for this problem, and the space complexity will be order of n also, because I have taken the priority queues, both the queues, and it will be k, where k denotes the maximum element that's been offered to queue, because not all elements will be within the queue, right? So it shouldn't be order of n but order of k. So this is the time complexity. That is it. That is what I wanted to do. Thank you for watching the video. Please like and share and subscribe. Thank you.